Okay, so today is the last lesson for this week. This will be a combination of what we've covered so far, plus what you've probably already seen in grade 9. So we're going to be talking about linear relations and rate of change, okay? So those are the two, I guess, notions that we will focus on today. But I think you've already seen this in grade 9, so for some of you it might be a refresher. But I'm not sure, right? Because again, I didn't do my high school here. I did that in Montreal. So what with the starter question, right? If you could pause and maybe try answering these questions, that would be awesome. But what they're essentially doing over here is they have a table of value, right? And they are representing the table of value using this graph, okay? Now, obviously, this is a function, right? In the table of values, you can see each. So let's just, for simplicity, let's call this x and let's call this y, right? And you can see for each x value, there's exactly one y value uh, associated, okay? So this is a function, right? So using the table of value, it's straightforward. Now using the graph, it's also straightforward because as you can see, each point will pass the vertical line test. Okay, so at each point, your graph kind of like intersects that point only once. Okay, so which basically means that for each x value, right, 5, you only have one y value. Okay, so this graph is a function. Okay, um, but it's not, it's a graph of if you want whole numbers, right? Not real numbers, because we're talking about toppings, right? So table value and graph shows the cost of pizza up to 5 extra toppings. So you cannot have like 1.5 topping or stuff like that. So that's why it's not connected, okay? But if you were to connect that, then you would have a nice line, right? Which is what a linear function is supposed to look like. Linear comes from the word line. But anyway, um, let's try to answer a few questions. So what patterns do you see in the table? Okay, what patterns do you see? Well, in the table, right? So as you can see, if the x value, whenever your x value increases by 1, right? Whenever your x value increases by 1, your y value is increasing by 0.75, okay? 0.75. And this is true for all the table values. Even let's say these ones at the end, right? You're increasing by 1, but this is also increasing by 0.75, okay? And this is crucial, okay? This is what we call the rate of change. The rate of change here is a constant, okay? So if your x value is increasing by a certain amount, in this case it's 1, doesn't have to be 1, could be anything. Your y value always has to increase by the same amount, okay? Okay, if the x value is increasing by that same amount, okay? So that's why it's a linear function, okay? So that's the pattern. Write a rule for the pattern that relates the cost of the pizza. So for this one, okay, I'm gonna answer it over here. So y is equals to, because it's increasing by 0.75 every time, so you're gonna have to multiply 0.75 by x, okay? So 0.75x, but if I do that, I have a problem, right? Because at 0, I'm not at 0. At 0, right now as it stands, if I plug in x is equals to 0, my y value will also be 0, but I'm not at 0, right? At 0, I'm actually at 12, so you're gonna have to add that 12, and this is how it goes. Okay, so the coefficient of your x will always be the change in in your it's actually going to be the change in y divided by the change in x. Okay, so 0.75 divided by 1 is just 1. And this is kind of like your initial point. Okay, you're starting out off at 12, and now you can kind of check if you're right. So plug in any x value, right? So if you plug in x is equals to 3, do 3 times 0.75, and then add 12 to it, you should get 14.25. Okay, so you could also check this. How are the patterns in the table shown in the graph? Well, in the graph, what you see is every time the x value increases by 1, the y value increases by 0.75, and that's true for every point. Okay, so it's kind of like it, if you think about it in terms of this these steps, if you want, right? They all look the same, right? The height is increasing by the same amount, but we'll talk more about that a little later. Okay, so what this basically means that all the points, right, are equally apart in the sense that like they're equally apart in terms of x distance, right? So let's just compare this red point to this blue one, right? So it's the same thing. Okay, this length and that length, it's the same. The height is also the same. So the rate of change is the same. Okay, and we'll talk a little more about that a little later. Um, so that's the pattern, I guess, that you see in the graph. And another pattern, I guess, the most obvious one is the fact that if you connect the dots, right? If you connect the dots, because the rate of change is the same, you're going to get a nice looking straight line. Okay. And the final question is, how can you tell from the table that the graph represents a linear function? How can you tell from the table that if you connect the dots, it's going to be linear? By looking at the change in x and the change in y, right? So it has to be the same everywhere. Okay, if it's the same everywhere, then it will have to be a linear function. Okay, so by looking at the rate of change. Okay, so um, if you want, yeah, just by looking at the rate of change, right? So by looking, and I'll define rate of change a little later. So by looking at the rate of change. Okay, and again, I will define rate of change shortly. Okay, so this is kind of like a review, if anything. If it did not make too much sense, don't worry too much about it. We're gonna, get to this point. I think you've already seen this in grade 9, but if you've forgotten, this is a good refresher. But if you're still a little confused, let me continue, and then hopefully everything will make more sense. Okay, so um, as you can see right now, we're gonna talk about the starter question. So we can identify that the function is a linear function in many ways. One way is to look at the table of value. Now, if your x value, right, the change in your x value, if it's constant, so every time it's increasing by 100, like I said, it doesn't have to increase by 1. It could increase by whatever. I think in grade 9 maybe it was always increasing by 1, if I'm not mistaken, right? So if the change in your dependent value, right, independent value, which is x, is always the same, then the change in your y value has to be the same as well. Okay, so so I guess they kind of like summarize this down here. So a constant change in independent value. So um, let me just change the colors so that you know the difference between dependent and independent value. So independent value is your x, okay, results in a constant change in your dependent value. Y is dependent, right? Depending on the value of x, your y will change. Okay, so this is one way to see that it's a linear function, right? The change is constant. Okay, and your okay, so for a linear function, a constant change in independent variable will result in a constant change in the dependent variable. Okay, it's kind of like what you see up here, but you can also see this in a graph. Okay, in a graph. So in a graph, essentially, what will happen is we're going to talk about rate of change, but in a graph, if you plot those points, you'll see that if you connect the points, you're always going to get a straight line. Okay, the line might look like this, it might look like that, it might look like this or whatever, but it will still be a line. You're not gonna see something like, for example, something like this. Okay, something like this. This is a curve. Okay, it's not a line. Okay, it's a curve. In grade 10, you're gonna see straight line. Okay, so straight line. So by line, we mean a straight line. Okay, so the rate of change. Okay, so here they're talking about the change in the dependent variable, right? So it's kind of like the height of this triangle, and the change in the independent variable is the base of the triangle, right? So the difference between the x values, the two x values, is the change in your independent variable, and the change in your dependent variable in y is the difference between the two y values. Okay, so it's kind of like if I were to draw this over here, these are your 2 points, right? Um, this this height of the triangle, right? This tells you the change in y. Now in math, change in y, we call that delta y, okay? Delta y. Delta just means change, and the change in x, right? The distance over here, right? This, the change in the x coordinate, we call that delta x, okay? So the formula for rate of change, okay, rate of change, I'm gonna give it to you. Rate of change, right, is equals to let's just let me be consistent with my colors from what you see in the diagram over here. Okay, so let's just erase this. Okay, so the change in y over here is given in blue, right? So change in your y, delta, and then this is given in green. Okay, so right. And when we do examples, this will hopefully make more sense. Okay, so it's your change in, it's always the change in y over the change in x. Okay, so the change in y could be a lot of things. One way to kind of like make it easier for you, it's always y2 minus y1 over x2 minus x1. Okay, so if you want, okay, if you want, well, what do I mean by y2 and y1? Okay, so each point, let's just go back to our triangle. Each point will have an x coordinate and a y coordinate. Okay, so let's just start with this point over here. Okay, this point will have a, you can pick any two random points. Okay, so but I'm just focusing on this one. So this point will have an x coordinate, right? So my x coordinate will probably be let's just, whatever the x coordinate is. Okay, so let's just call it x1. Now because my x coordinate is x1, my y coordinate has to be y1. Okay, the numbers have to match. Okay, so the y coordinate, again, I'm using blue for y, green for x. Okay, now this point over here, because this is x1, then this has to be x2. Okay, and the y coordinate of this point will be y2. Okay, not too sure if you've seen this formula before, but this will make more sense when we apply it. Okay, so this is the formula. Rate of change is equals to the change in your y, divide by the change in x. Okay, so how do you find the change in y? Find any 2 points on your graph. Okay, find any 2 points. Do the y value of one of the points minus the y value of the other point, and divide that by the x value of one of the points and the x value of the other point. Okay, so let's apply this. Okay, let's apply this. You know what? We're actually going to be applying this a little later. Okay, so towards the end. So let's practice something first. So this question is simple. It's asking you which table values represents a linear relation. Okay, so as you can see in this table, right, your c value, right? So you can kind of think of it as your x is increasing by 5, and your y value is increasing by 9, and that is true for any point in the table, right? Here, like let's just focus on the last two. Here, the change in x is 5, and the change in y is still 9. Okay, and this has to be true for every point. I don't have the time to do this, but if you work this out, you'll see that the change is always plus 9. Okay, the change in y is always plus 9, and the change in x will always be plus 5. Okay, so plus 5, plus 5. So okay, but so this is a linear function. Okay, so this is linear. Okay, now this one probably will not be linear, but let's see. So the change is 5. Okay, so the x is good. X is always increasing by 5, right? So x is always increasing by 5, but as you can see, the y already here, this one is increasing by 75, and the next one is increasing by 225, I think. Okay, plus, so already there you can stop. Okay, because This is 75, this is 225. It's not the same thing. Even though, right, your x values are increasing by the same amount, your y values are not increasing by the same amount. So you can stop over there and conclude that this one is not linear, okay? So in a similar fashion, I'm going to ask you to figure out which one of these is a linear function. Okay, so pause the video, figure out which one of this is linear. So I'm going to continue. So the change in x seems to be plus 20, right? It's plus 20 everywhere. The change in y over here is plus 1, and then over here it's plus 2, okay? Even though this is also plus 20, right? So this is not linear. Okay, so I don't have to check anything else because already here it does not satisfy the condition. So this is not linear, and I'm not going to bother continuing because this at this step I know that it's not linear. Now this one over here, it's increasing by 60, and as you can see, all of them are increasing by 60, right? All of them are increasing by 60. Now what's happening to the y values? All of them are increasing by 3, okay? All of them. So this is linear, okay? Now, I guess one thing that I should have pointed out is what is the rate of change? Okay, so let's find the rate of change. Um, Even though the question is not asking you to find that, if it's linear, only then can you find the rate of change. Okay, so rate of change, right? It will only work for the linear function is equals to the change in y over the change in x. Okay, but what is the change in y? It's just 9, right? Everywhere it's 9, and the change in x is 5. So this is your rate of change. If you want, it's 1.8, I think. Okay, let me use my calculator. 9 over 5 is fine because that's a simplified fraction, but I know that you guys really love your decimals. So 1.8, okay, that's your rate of change. Now in this question over here, this is linear, right? The table on the right is linear. So I can actually find the rate of change. Right? Rate of change will just equals to change in y over change in x. So the change in y is 3, the change in x is 60. And that's, it's 1 over 20, which is 0.005 maybe. 3 divided by 60, 0.05, 0.05, okay? 0.05. So that's how you find the rate of change, okay? Now we have just couple of more examples and then we're done. Okay, so identify the independent and dependent variable. Okay, so I'm just gonna go with the independent. I'm gonna go with red. So the independent one is time, okay, and the dependent one, I'm not gonna rewrite this. Dependent one is your y one, your y axis, right? So the I guess the label of your y-axis. So this is dependent, okay? So independent is time, dependent is volume. Now determine the rate of change of each relation, okay? Then describe what it represents, okay? So when you're finding the rate of change, you have to pick 2 points in your graph. Doesn't matter which one, just 2 points that are really well defined, okay, that have nice coordinates. So what if you pick this one, okay, this one over here, and let's just skip this one. Let's just say, I'm actually going to go with this one because this one also has nice values, right? 80 and 4,000. This one will be tricky because then it's going to be 60 and 3,000. But like, you're going to have to kind of like figure that out that it's 60 and 3,000, right? So always go with 2 points that have nice coordinates. Okay, so this one, let's say, and this one. You could have also gone with this one. It doesn't really matter which one you pick. Okay, now once you find your 2 points, then you have to call this point, let's say if you're calling this point x2, y2, then this point has to be, right, this point over here, let me use a different color. This one has to be x1, y1, okay? And this is where when you apply your formula, it's gonna be helpful. Okay, so let me just be consistent with my color. So this one, I'm talking about this one in green, and that's the red one. Okay, so remember, rate of change is right. So let's write this down. Rate of change. This is for the first graph. Okay, so and maybe if you want, I can just draw arrows. So rate of change for this one is equals to the change in y divided by the change in x. Okay, so how do you find the change in y? Just find the difference, right? So let's, the formula tells you to do y2 minus y1 over x2 minus x1. Okay, so I've just chosen this to be my x2 and y2. If you chose this to be your x2 and y2, it would still work. Okay, it doesn't matter. But once you define x2, make sure that the y coordinate of your x coordinate matches. Okay, if this is a 2, then this has to be a 2. This is a 1, then that has to be a 1. It doesn't matter which one you pick to be 1 and 2, but once you pick them, just be consistent. Okay, so let's continue. So y2, my y value is 6,000, right? Y2, this coordinate is 6,000, and my y1 is this one, that's 4,000. So 6,000 minus 4,000 divide by x2 is over here, so that's 120, minus x1 is this one, 80. Okay, so 80, and then what should I do? I'm actually running out of space, so what I'm going to do is I'm just going to copy this down over here. Okay, and then I'll continue in this direction. Okay, so let's just erase this. So this gives me 2,000, right? 2,000 over 40, and then you can cross out the zeros, and that's probably 50. Okay, but just to be sure, I'm just going to use my calculator. So 6,000 minus 2,000 divide by 120 minus 80, and that's 120 minus 80, that's 40, that's 2,000. Oh, sorry, 6,000 minus 4,000, not 2,000. 6,000 minus 4,000, yeah, it's 50. Okay, now for the rate of change of the second one, so let me do the second one in a different color. Let's say purple. Okay, so this one will be, so this one over here, right, is done in purple. So rate of change is equals to the change in y divided by the change in x, which is equals to y2 minus y1 over x2 minus x1. Okay, so pick any point. So let's just go with again, the points that are really visible. I think these two are really easy, this one and this one. Okay, so I like to, again, it's your choice, whichever one you want to pick to be your x2. I usually pick the x2 to be the, bigger x coordinate, right? So the one that's on the right side. So this is my x2, so this is going to be my y2. It doesn't matter. You could make this your x1 and y1. But because this, I've chosen this to be x2, y2, then this has to be x1, y1. Okay. So now let's apply the formula. So y2, right, my y coordinate of this point is 0 minus y1. Y1 is actually 6,000. And then you divide this by x2, which is, I can't really see, but it's in between 40 and 80, so that's 60. So 60 for my x coordinate over here, and my x coordinate over here is 0. So this is just minus 6,000 divided by 60. So this is minus 100, okay? Minus 100. So determine the rate of change of each relation, then describe what it represents. Okay, so what this is telling you is that you're filling the tank, right? So rate of change tells you what happens for every time you increase your x value by 1, what happens to your y value. Okay, so that means every time, for every time your minute increases by 1, right? Every time the time increases by 1, 50 liters are being pumped in to your tank. Okay, so this is what this tells you. And this one tells you that, um, so, right, this tells you that for every minute, right, every minute your tank is losing, because it's a minus 100 liters of water. Okay, But don't worry about that. Okay, don't worry too much about that. What it means, I'm just interested in how you find the how to find the values. Okay, so pause the video, do this one on your own. Okay, do this one on your own, and that will be it for today. So this will be homework. So please do this on your own. I'm gonna continue anyway. So I think this video is a lot longer than I had expected. So identify the dependent variable. So this is my dependent. Let's just be. I think independent was always my red color, right? If I'm not mistaken. So let's just be consistent. Yeah, independent is red. Okay, so independent is always my X and dependent is my Y. Okay, so dependent is my Y. So that's done. And determine the rate of change. I'm just gonna say R to save a lot of space. Okay, so pick any 2 points you want. I'm just gonna go with this one and this one. You could have chosen this one if you wanted to. Okay, it doesn't really matter which one you choose. Okay, so um, let's just go with the two endpoints. So this one and this one. Okay, so this will be my x2, y2, and this over here is my x1, y1. Okay, so r is equals to y2 minus y1 over x2 minus x1. So the y coordinate of this point is 1600 minus the y coordinate of this point is 0 over x coordinate of this point is 80, and then minus x coordinate of this point is 0. Okay, so this will just be 1600 divided by 80, so you can cross out the zeros. 8 times 2 is 16, so this is probably 20. Okay, now the next one, same idea. Okay, so I'm going to do this in purple. So pick any 2 points you want. Okay, I'm going to go with this one and this one. Okay, because they have 0, so it's actually an easier choice, but you can do whatever you want. I'm going to call this point, again, I like to call the bigger x value always. This is just my way of doing it, but it doesn't have to be this way. I always like to call x2 the bigger one of the two x values, and y2 it doesn't really matter to me. Okay, so this is x1 and this is y1. Okay, so r for this one in purple is equals to y2 minus y1 over x2 minus x1. Y coordinate of this point is 0 minus y1. So y coordinate of this point is 1600. And then I have to divide this by the x coordinate. X2 is over here. So this is actually, I think, 40. I'm going to erase this to see a little better. Yeah, 40. And then minus the x coordinate of this point, which is 0. So it's just minus 1600 over 40. Okay, it's kind of tough, so I'm just gonna move this a little down. So over 40, and then you can cross out the zeros. So 4 times -4 is minus 16, and then a 0. Okay, so I'll just double check my answer. Minus 1600 divided by 40 is minus 40, and 1600 divided by 80 is 20. Okay. What does it represent? Well, it's just telling you that for every minute, right, that goes by in the first situation, right, for every minute that goes by, your tank gets filled with 20 liters of water, okay? Um, and I will talk a little bit more about that later, but for now, let's just I'm just gonna verbally say it, so don't worry too much about this. And for this one, for every minute that goes by, your tank loses 40 liters of water. Why it loses? Because there's a minus sign. Okay, so that is it. So this is your homework, guys. Please do the homework. And if you have any questions about this, please send me email. Okay, send me email. If I get a lot of email, I can just make a separate video and answer those questions. Um, and I can also help you on Thursday. I'm going to be holding office hours on Thursday, okay? But that is it for today and for the week, okay? So take care, guys. Thank you so much.